Can you guys see my screen?
Yeah, it's visible.
Yeah. So can anyone tell me what are the services we have discussed so far?
Service 10, service 11, service 27.
Then what else we have discussed? What else we have
Multi-frame.
discussed? Very good. We have discussed multi-frame, and then service 10, 11, 27. That's it, huh? Hello guys, I'm asking question.
Yes, ma'am.
Yeah, that's it.
Okay. So next we'll go to 28. Okay. When it comes to the 28 service, okay. 28 service is used to control the communication. Control the communication of the ECU. So now tell me, I think we have already discussed. So in the CAN network, we have multiple ECUs connected. ECU 1, 2, and 3. So now tell me, whatever the inputs is received by the ECU, those are all messages. And whatever the output we receive from the ECU, again it's a message. So we have discussed there is a name for this and even for the output from the ECU and input to the ECU. What are those names?
RX and TX messages.
Very good. So whatever the input will be received by the ECU, that is called RX messages, and whatever the output we will get from the ECU is called TX messages, nothing but R frames. TX frames or RX frames. Okay. So now by using the UDS, you can control whether this particular ECU can able to receive any like all the inputs, nothing but you can control the this type of like when it comes to the ECU is receiving the inputs by using the UDS, you can control the ECU whether this ECU should get the inputs or it should not receive any inputs, nothing but you can stop this RX messages by receiving in this ECU. And also about the TX frames, you can control this ECU whether ECU has to provide the output or you can avoid, I mean nothing but you can make this ECU to not to provide the output. Okay, so this is what is called the control communication of ECU, that this can be done by using the 28 service. So in the how they are doing, of course by using the sub function 0001 1011, sorry 1011 is not there, only 0001 nothing but 2 00 where it is. Okay, come here. 28 00 28 01 28 02. So by using these sub functions, we can control the communication of the ECU. So now tell me, I will write down 00 means enable both RX and TX frames. Okay, next time whenever I ask, you guys have to tell me the response for this. Some in between I will ask to I want to disable the TX and I want to disable the RX, or enable only RX or disable only TX. So like that you guys have to tell me the request and and response. Okay, so it is already there. So 00 means enable both RX and TX. By default, this is the stage it will be. ECU will be getting the inputs and it will be providing the outputs. So intentionally, if you want to disable or enable particular frame, nothing but if you want to enable the RX and disable the TX for your testing, For your testing, you have to create the scenarios. That time, if you want to enable only Rx and disable the Tx, nothing but you are disabling the output from the ECU. That time you have to provide the subfunction 01. And if it is a 02, you will be disabling Rx and enabling Tx. And if it is 03, you are disabling both. Nothing but this is the request which you will be sending to the ECU. If the ECU provides a positive output, nothing but positive response. So what would be the positive response? Now if you request this, what is the DLC for this?
4800.
48.
68
Not, not 68.
68.
Yeah, 6800. If you get
00.
the positive response like this, now you have enabled both the Rx and Tx. By default, it will be enabled. If you are disabling and then you want to enable, this is the request you will send to the ECU. What is the DLC here?
Two.
Very
Two.
good. Here?
Here also 2.
Very good. So now similarly by using the different subfunction, you can control the communication of the ECU. So if the ECU is sending positive response like this, how we have seen here, it only changes the subfunctions according to your request. Either you have to disable the Rx or disable the Tx or disable both, or enable the Tx and disable the Rx like this. So you can control this communication of the ECU by using this particular service 28. So is it clear? Any doubts on this?
No.
Okay, so if there is no doubts, I am moving on to the another service. Okay, so to understand 85 service, first I want to explain the service 19. So before going to the service 19, I'll finish it off service 22. Okay, so the next one is service 22. So service 22 is nothing but read data by identifier. Okay, so usually by using this service, the identifier what we are calling is will be a internally, nothing but okay, all this information is not required. Nothing but what I mean to say is these are the identifiers which will be used internally. Whenever you are releasing your software to the customer, you will not be enabling this feature for them. So this is for internal purpose to understand few things and to make the testing easy and to make the if something is not working, then if you can just use one of the identifier and read the data and understand what is wrong. Otherwise you have to sit and you have to spend a lot of time understanding where this particular variable which is a output from the one of the function is getting stored, in which memory it is getting stored. So for that you have to spend time. If you have a a specific identifier for that, you can just read that identifier. That is the use of this service 22. So what is exactly that read data by identifier meaning? So let me take one of the example. Now there is a something called power mode, right? We have already discussed the power mode, how many power modes are there in the car. So, so how the code will be for this? There will be a one of the sensor which will be identifying this power mode and which will be sending to our microcontroller. This is a one of the input for the our microcontroller to understand whether the car is in a static mode or it is in dynamic mode. Otherwise it is in a accessory mode, which is like um, your engine is not running. You have started the car like nothing, but when you are turning on, the first one is off mode. Now you are in off mode. Now anyway buttons are there, but before if you turn on one, that is called a accessory mode, where your radio FM everything everything like radio or AC, everything will be on, wipers, doors, everything will be on, but not the engine. Then if you turn on, like, do one more round, that is called an ignition, where your engine will start. Okay, so that's how it, like, if you are not still, not in a moving state, that is called a run mode. Whenever you start moving, nothing but whenever you provide the acceleration and your car is moving, that is called a propulsion mode. Okay, so that is the power modes which will be identified by one of the sensor and will be providing to our ECU as a input. So now when how, like, there should be a code for the sensor where it is exactly identifying, and there will be a written value from that function to show that what is the power mode. So this power mode, something like the variable will be p underscore m, which will be having a value like 0, 1, 2, 3, 4 or 5, like this. So these values, how it will be? It will be storing in one of the memory. So if the power mode is identified as 0, then it will go and store in one of the memory. If the same variable having the value 1, nothing but accessory mode, it will go and store in the same memory. Correct, right? There will be a one particular memory with the 2 bytes or 3 bytes or 4 bytes, depends on the size of this particular variable. It will be storing on this memory. So whenever you want to understand what is the power mode, whenever for the testing purpose or to develop the what, like, to understand what is exactly you want to set. So assume you want to set the power mode to one of the particular power mode. So otherwise you have to read what is the power mode currently or previous power mode. So that time what you have to do, if you do not have the identifier, what you have to do, you ideally you have to open your white box, nothing but IDE, where you write the code, and you have to understand where this particular variable is storing in the memory, how many size of this, how much is the size of this particular variable, and read this memory, and again create the situation or update this variable for the other power modes and read this memory. So instead of this, for the to make the end user nothing but a serviceman and the what I can say, the tester work easy, what they have done, they have come up with the identifier. Nothing but they will provide some of the identifier like F1, F0 or F3, F4 or something like this. It is typically depends on the client like what I can say, client request. So what happens if they are providing identifier F1, F0, F1, F3, F2? It could be anything. There is no specific. It keeps on changes. Just 2 bytes of identifier they will be assigning like this to this particular memory, and they will provide the name called this power power mode identifier. So by using this identifier 22 F1 F3, if you read this, what you will get, if it is providing the positive response plus 4062, then you will get F1, F3, and then the power mode value, nothing but what is exactly stored in this memory location. Here you are not reading the memory location, and you don't have to get to know where exactly it is storing, because by the software developer it has been fixed. Nothing but this memory has been assigned with the nothing but a data identifier called F1, F3. So to make your work easy, F1, F3, if you read it, you will get what is the power mode, nothing but what is the value stored in that particular memory. It is useful for the developer also, because developer also does the testing. If you are developing some UDS, if you are developing in the UDS 22 service, whenever you do this, you will test it, whether it is accessing the same memory. At the once after the software goes to the production, if something escalation comes to you again, and you will not go and search where is this particular variable is getting stored in the memory, you all you want to do is just run this command, nothing but run by using the service 2022 F1, F3, you will get what is exactly stored in that memory. So this is what is called read data by identifier. You are getting the data, nothing but reading the data by using the identifiers like this, but that identifier internally in the software has been mapped to the memory. Understood?
Yeah.
Okay. So similarly, we have one more called 2E. This is write data by identifier. Write data by identifier. It is same as 22 where you will only read it. Okay, but by using the 22E, you can also write that memory location without even knowing that memory location, because this identifier will be already configured with that memory location. If you send 22E F1 F3 with the data 03, that time if the memory, like as I already told you, F1 F3 is already configured with the memory. Whenever you are writing this DID, what is exactly happening inside the software? So it will be writing the memory location which has been aligned with the or configured with this DID. So if you get the positive response 6E F1 F3, then nothing but 03, which is a or run power mode has been written on this particular memory. And this write data by identifier is not applicable for the every DID which is present in your project. Some of the memories are restricted. You cannot write those memories. You can only read those memories. That too you can read only by using the 22 service if it is nothing but if it is configured with the UDS. You cannot read every memory location. If that particular memory location is configured with the DID, one of the DID, then only you can read that particular memory, nothing but a memory location by using the DID. Clear?
Yeah.
Okay. So read and write data by identifier, and then which one we discussed? 28, communication control. So all these three are clear, and I can show you in practically how it looks like also. In one project you will be having nearly 25 to 30 DIDs. See, this is routine. 28, communication control we have already discussed. 2E, write data by identifier. If I go here, this is how the requirements you will get it, but not in a PDF, in the in any of the requirement configuration tool. You will get this. If you export, you will be exporting in a PDF or Excel sheet. That's it. Okay, we'll come back to negative response later. Not a problem. That is anyway at the end. See, F085, FF00, FF01, FF02, F120, F03 to FFFFFF. So like this, they can give any of the identifier, but you don't have to worry. It will be present in the requirement itself. Okay, and there will be a part number for your software version, hardware version, and hardware part numbers, software part numbers. So all these things will be read by the using service 22 itself. Okay, but you cannot write all those information because it is restricted by writing. That is the reason you cannot write it, but you can read all those information, software version, hardware version, part numbers, which hardware you want to use it, everything will be, the manufacturing information also will be present in the software, right? Even though you are not writing that manufacturing information, because your module would be only UDS. As a UDS developer, what you will do, you will just configure that particular memory address to this DID. See, this is the ECU supplier code, and you as a only developer, you will not be knowing what is that supplier code. That will be present in the memory already. Okay, because you will receive the softwares from the different companies based on the layers. Your job is only to write some of the only little code in one of the application. You will not be knowing where you get, like you will be knowing where you get if you talk, yeah. So but you will be getting the code from the different companies, and there nothing but a your client would give, or different like vector would give the code, or eb can give the code based on your company, where which company you are going to. So in that, by you that memory you will just link to this f1 a1, that's it. Okay, so like this, there will be a multiple DIDs where you will get it. Calibration part number. What is calibration?
It is the process to check actually working correct or not.
Sorry, can you please come again?
It is the process to check process is correct or not, working fine or not.
I asked, like you answered calibration part number. It's fine. I'm asking what is calibration meaning?
See measurement values.
Measurement values of what?
Comparison to sensor.
Mm-hmm. How are we using calibration?
With respect to time, it will be changed. That is called we can calibrate.
Okay. Then any other answers? Okay, so the first of all, whenever you are flashing the software, I'll come what is that calibration meaning. Whenever flashing the software, you will flash three softwares basically. One is, second one is, come on guys. Even though you are developer, you are going to generate three files.
Reset.
Sorry,
Reset.
not reset. Application, and then last one is calibration.
Default.
Bootloader is applicable by the bootloader developer. Application will be like, for the application there will be a multiple developers based on the module to module, like UDS, CAN transceiver, sensors. In sensors also different sensors. So in for one project there will be a 10 to 15 members of developers. One module will be developed by one person. So that they will be integrating it. So in this application is a one of the software, and then calibration will be given by the system team, who actually knows how the system has to behave. Nothing but, so what is exactly calibration meaning? So whatever you guys said, it is right. But before that, there is a basics of this calibration. In the calibration, if you take one sensor, so how do you consider the minimum value of this and maximum value of this? How do you understand this minimum and maximum? So let's take an example of pressure sensor. Okay, so for our, to create one of the system, there should be some minimum pressure where you will set by default, and you will be having a limit. If the pressure reaches this 69 Pascal, so there should be a limit for the pressure sensor also, right? You cannot, simply use the sensor how much you want. Nothing but how, like how the sensor detects. So now assume pressure sensor is detecting the pressure as 70 Pascal or 100 Pascal. So it keeps on changes based on the weight or the pressure you keep on the seat or anywhere. Correct, right? So let's say assume you are keeping something about which is 300 kgs, and you have kept on the seat. And there will be a sensor who identifies the weight and the pressure which applied on the seat. So does it valid?
No.
Yeah, so how are you getting know the software it is not valid, it is invalid with these limits, correct, right?
Yeah.
So all those type of values, what is the minimum value, what is the maximum value, what is the, there will for calibration also there will be a memory fixed like 128 KB. In that there will be a particular values in the okay, 120 inside 128 KB completely memory will be fixed for the calibration. Inside that, from starting address to the ending address, each and every byte says something. Whenever you are flashing the calibration, what is exactly happening? It is getting, flashed inside the ECU in that particular memory. So whenever it is stored inside the particular memory, so your code will be using that. So where you are saying the minimum and maximum value is this much. So if it is going beyond that, then it is invalid. So like this, assume that like only autonomous car is something new. Okay, so assume other systems like brake systems. It is present in the market from many years. Correct, right?
Yes.
So how are they, like, why are they still working on this brake system? Then when we have, like kind of we have brake system like from many years. So how exactly they are, improving? What exactly they are improving? How exactly they are improving? And how are they get to know that what is the field issues? So every time whenever you report an issue with the manufacturer or anything, like there will be something called EDR inside the card, which will store everything, which will be read by the customers. They will understand if something has gone inside the car. That's how they will get to know something they need to improve or something they need to update it. These are all called field experiences. So by using these field experiences, they will update their calibration values, where they improve themselves with the limitations, where they come up with the new solution, where they come up with the new formulas. Getting? So in the calibration, it will be containing manufacturing values and the limits and also the field values, previous field values. Based on that itself, they will create the calibrations. Understood?
Yeah.
Okay. So if that is clear, we have 22, 2E, and then 28.
28.
Yeah, 28, 22, 2E is over. So to understand 85 and 14 service, you have to understand the 19 service. Okay. So anybody knows what is 19 service? At least someone who is watching the YouTube.
Communication control.
That is 28, right? Just now we have discussed.
Yes, yes.
Yeah, I am asking about 2019.
Read it is information.
Very good. So what is that? Can you please elaborate?
Okay. Data transmission information.
Data transmission. Which data? Yes, come on. Which data? When you say data transmission, meaning?
Okay. Yes, not exactly. I don't know. Okay, but just know that.
Okay. So the first of all, what is the purpose of UDS? The main purpose?
That it is okay.
Sorry?
Diagnosis.
Diagnosis. Correct. So what is the meaning of diagnosis?
Like treatment. Okay.
Okay. In the respective of electronic devices.
Fix the issues. Okay. Fix the errors.
Yes. Yes. Fix the issues. So how are we getting know these issues or faults? How are are we getting know this fault which is present in the
By using Canon.
by using the UDS I'm asking. Kenoi is just a tool. By using service 19. By using the service 19 itself, we read what is the issue with the ECU. Nothing but what are the faults are present in the ECU. This is very much important in the UDS service. Okay. So now, when we say fault, I'll take one example of fault. Otherwise, I can show how many faults will also be present. If you consider one project, fault definition, yeah. This is the requirement spec for the fault definition. Nothing but what are the faults are applicable for your project or your product. Okay. So as you can see here, seed presence are low fault, seed presence is ruptured, fluid level, presence of supply low, temperature sensor high, low, microcontroller fault, RAM failure, seed not calibrated, temperature open, ALR sensor faults, CAN bus fault, CAN communication error fault, calibration checksum fault, EON checksum fault, ROM checksum fault, stack overflow, EEPROM program. So these are all the, like this in this many faults there will be a few similar faults in your project also. Okay, it's here it is like there are few default faults which will be used in every product, like CAN burst of CAN communication error, calibration checksum, EOL checksum, ROM error, stack overflow, EEPROM state, ignition high, ignition low, CAN versus message failure, CAN versus timing failure, watchdog failure. These are all the by default failures. In our project, we just used 4 sensors. Those are the 4 sensors faults only the specific. Other than that 4 sensor faults, everything is generic in every product. Okay, so what are these faults basically? Why are we, categorizing this fault? So what are faults first of all? What are faults?
Mistakes we had done.
Sorry?
Mistakes like mistakes.
Mistakes. Mistakes by whom?
Human.
Human. That is called errors, not faults. According to the quality management or the ASPICE process, the mistakes from the human is called errors, not the faults, nor the bugs. Yes, come on. Then to
Then
identify
system.
the mistakes from the human, do you think we have this many?
I think it's a zero.
Sorry?
Zero is a false.
Zero the faults. I'm asking first of all, what is false meaning? Why are we having these faults? First of all,
Not getting exact input of what you are giving.
not getting exact output what you have given. No. Okay. So the first of all, these faults is not belongs to your code or some it is not about the person or the mistakes of the human or whatever. It is all about the complete system. Okay, it's all about the complete system. So what are the projects you guys have mentioned in your resumes?
Okay, Adas,
ADAS project, is
fabric.
it?
Yeah.
In the ADAS project, which feature you have guys have mentioned? Traffic recognition
AES.
signal.
AES.
Can you please
Autonomous
elaborate? Autonomous
emergency braking.
emergency braking you have mentioned, not the traffic sign signal recognition, sign
Both TSR
recognition,
also.
both. Okay. So when you let me consider that project now. Traffic signals recognition, TSR. So it is a one complete system. So where it is taking the inputs from the radar and also the camera, and then it will take the output, nothing but an action. Correct, right? Where
Yeah.
if the 30 kilometer is the sign which is getting, if it is if the car is as its own control, then it has to reduce the speed if the speed is high. If the control of the car is by the to the driver, it has to provide the warning indicator. Correct, right? Simple, simple, very requirement, simple example I have taken now. So now tell me, assume there is a one camera is not working. Camera is not working. So what happens? So camera will not provide the input to the ECU. So what happens to the ECU? ECU, do you think ECU will take care even though there is no input from the camera? Of course, assume, okay, there is a one like what I can say, one cover or something came on the camera and it is closed. And something, nothing but a blockage, I mean to say. There is a blockage for the camera, so it is not actually identifying the objects or capturing the images. What will happen?
AC won't respond. Okay.
ECU will not respond. Why ECU will not respond? It is
Because
camera we are talking about. Then if the ECU is not responding, then how would you get to know that there is a wrong with the camera? Okay, first of all, you are telling ECU will not respond, so how would you get to know ECU is not responding? If it is not
we are not
responding, then
getting
what
any
will you
input
do?
from camera, right? No, no, we are not
Uh-huh.
getting any input from camera, right? That's why ECU
Huh.
won't respond. Okay, about the signal recognition.
No. If the ECU is not responding, then it is a problem. Nothing but a ECU itself is a complete one system which is handling your TSR completely. If it is not responding, then just assume, just imagine autonomous car. Do you really think if the ECU is not responding, then do you really think you can just simply get your car to the service station? And you are simply sleeping inside the car by assuming your car will take you by providing the access to the car with the ACC cruise control, and you are simply sleeping, and this ECU is not responding in the sense, what is that? It is not like, according to you, whenever the camera is not working, ECU is not responding now. So this functionality itself is not working. So what exactly happens? It is not going to take care. So even though there is a car comes in the front, it is going to hit on that. Correct, right?
No, okay, but we will use radars, right? Okay, ultrasonic. Okay.
That is also one of the input, right?
Yeah.
Huh. Then you said ECU will not respond.
In detecting images, okay, ECU will not respond. I'm telling.
Okay. The first of all, there is nothing called not responding. If the ECU is not responding, then like one with the car which is already on the field, this should not come up. First of all, the first thing, ECU should respond. That's how we understand what is wrong with the inputs or what is wrong with the outputs of the ECU. If it responds only, otherwise we have to remove the each and every part of the car and identify what is wrong with this ECU if it is not responding. If it responds only, then we only will get to know. Okay, so now it is responding. So one input is camera, another one input is radar. Leave about the radar because the overall system has to consider the input of the camera also and radar also. Even though one input is not available, then it is a problem. Okay, so now the camera is not sending the input to the ECU. Nothing but what is ECU? Inside there will be microcontrollers and so many other hardware components. So in that microcontroller, what exactly happening? This microcontroller or ECU wait for limited timing which has been mentioned. It could be 10 seconds or 5 seconds or 2 seconds. It will wait, and still it is not getting the camera input. It will set a fault. That communication error with the camera. It could be, name could be anything based on the manufacturer requirement. Name could be anything, but this is the scenario. where there is no inputs to the ECU from the camera, ECU will wait for some of the mentioned time by the developer. It could be 2 seconds, 5 seconds. Based on the requirement, developer will be configuring this time. So if the ECU is not getting the camera input for 5 seconds, then it will set a fault that I am not getting input from the camera. That's how the serviceman will understand, okay, there was a fault where the ECU couldn't ECU was not getting the input from the camera. Otherwise, he cannot even get to know. This is called a fault. This is called actually the communication faults. In faults also there are multiple faults. This is one of the communication faults. Similarly, speed. Your ECU gets to know what is the wheel speed. Every wheel speed is different, vehicle speed is different. So ECU will get the input from the every wheel speed sensors, nothing but every wheel sensors who is actually detecting the wheel speed. Based on this wheel speed only, your vehicle speed will be detected. So if this input is also not getting, then it will set the fault. These are the kinds of inputs. This type of faults is called communication faults. Okay. Now let's say radar is not working. Something happened and nothing but something. These cameras and radars are outside of the car, like mounted. So if something accident occurs, it will be damaged. Correct, right?
Yes.
So now it is damaged. And how will you make sure that, like, of course, radar will not send the inputs to the ECU. So how do you make sure your system is working fine? So again, what happens? ECU will set a fault and it will provide the warning indicator. If the fault anyway, you will get to know that warning indicator. For every fault, there is a 1 byte of data, where 7 bits, nothing but 8 bits. In this 8 bits, 1 bit is to identify warning indicator to be to given to the driver or not. So these type of faults will be always having a bit 7 to high, which is nothing but warning indicator should be turned on these faults. Whenever this fault set on the ECU, it will start beeping. Nothing but it will start warning the driver. Something wrong with the camera, something wrong with the radar. ECU is unable to get the input from the camera or radar. Understood? So like simple example, your handbrake. Whenever you not remove the handbrake, still brake is on, handbrake is on, you will keep on getting the red warning indicator on your dashboard. Correct, right? That is nothing but a fault
Correct.
where inside your ECU is getting like it's identifying handbrake is not released. So handbrake is not released and you are trying to start the car. So your engine will not allow you to start the car. Why? It has set the fault stating handbrake is not released. That is the reason when the warning indicator is high for that fault, then only you will get the indicator on your dashboard. Now understood what is faults meaning?
Yeah.
Yeah. So if you have understood the faults, so when you take your car to the service station by telling radar, like I'm getting this warning indicator, or radar is not working, or camera is not working, or you are not getting the output, or your back camera, whenever you are taking the reverse gear, by applying the reverse gear, your back camera is not turning on. So you don't know what is wrong with the camera, whether camera is wrong, or whether you are in your dashboard, wherever you get the picture, whether issue with the dashboard itself, you don't know what is wrong. Correct, right? That is the reason you will take your car to the service station. So when you take your car to the service station, he will do by reading the 19 service, which is to understand what are the faults have been occurred in the system. Okay, understood now what is faults?
Yeah.
Yeah, so in this 19 service, we have a different sub function. So which is 1901, 1906, 1902, 0206. So 1901 in the sense, whenever you request 1901, like request like this, you will get a positive response. 19 plus 40,
59.
very good.
59.
5901 with the number like x1. So which means this will provide number of faults. Nothing but in this, whenever you request 1901, you will get how many faults are present in the system. You will not get what are the faults are present in the system. You will just get, okay, there are 15. If the number is 15, then it which means there are 15 faults present in the system. Okay. So now you have to understand what are those 15 faults. Correct, right?
Yes.
So to understand what are those 15 faults, you have to request 1902. And one more I will come with the status byte. I will come to this because that is the again one of the big topic. So as of now 1901 you understood, 1902. 90, when you request 1902, 5902, and then you will start getting the DTC, diagnostic trouble code. So as we got to know, there are 15 faults. But how would you understand? Of course, you cannot get the name right. Whenever you know, as a tester, you will not, ECU cannot give you the name. It can give you the value like hexa values. That's how it is giving the hexa value. The binaries are converting into hexa. It cannot convert the binary to word. Correct, right?
That's right.
So, whenever you are reading the faults, you will get some value called F. Okay, I'll open this. So, it's better. Let me take ROM checksum because ROM memory everybody knows, or Stack Overflow. Anyway, everybody knows as a developers you guys are. So, here see DTC. What is the DTC is 9763. For every fault, there will be a number. That's how we'll get to know. We like this is for English because we understand English. That is the reason we gave the name in the requirement. Okay. So what happens if the this number 9763 is getting stored in the memory? When you read to understand what are the faults are setting in the setting in the system, what are the faults have been set in the system. If it is providing 9763, then it is called stack overflow fault. How will you get to know? You have to come back to your requirement. Come back to your requirement and search for this number. Oh, okay, 9763 meaning is stack overflow fault and it is setting in the system. For every system, there is a code. That code itself is called diagnostic trouble code, which is also called DTC. Clear?
Yeah.
Yeah. So when it comes to the 1906, in the 1902, as we got to know, we will get the 15 DTCs. That because there are 15 fault in the system. When you read 1901, you understood there are 15 fault in the system, but you don't know what are those 15 faults are. That is the reason you requested 1902, where you will get the DTCs, nothing but which are the faults are set in the system. So 15 faults are set in the fifth system. What are those? How would you get to know what are those? With the DTC, diagnostic trouble code. Clear?
Clear.
Yeah. So in the 1906, this 1906 is for the extended data information which you will get from the EC. Okay. So this is for the extended data information for one particular fault. So in the first case, you got how many faults are present. In the second case, you got to know what are those exactly the specific faults. And in the third case, 1906, you will understand more you will get more information about one fault. So what is that more informations are? So the one thing is fault occurrence, fault occurrence. The second one is aging counter. Usually by default, generally these are the will be present, but again it depends on the project to project based on the critical information, what they think that this is the critical information. The third one is the system is running. How long the system is running when this fault is active. Fault is active. I will come back to this active fault and history fault, but like this and etc. There are multiple, like after how many times, after how much time the fault has been set in the system. The software has to identify the fault, nothing but the system has to identify the fault one or two, twice or thrice. It is not going to set this DTC, nothing but it is not going to write this DTC in the memory when it is identified in the first time itself. It has to make sure, okay, this fault is again setting. Okay, so nothing but it's still the condition is still present. Still that someone is blocking the camera, like that. So twice or thrice it will be checking, and also there is a time. How often the system will check for the faults? It's every 10 millisecond. It could be every 100 millisecond based on your task. Nothing but you guys will create the tasks. 1 millisecond task, 2 millisecond task, 3 millisecond task, 1 second task, 2 second task, 3 second task. Based on that, it will be checking for these all these faults. Okay. So when it comes to the 1906, it will provide the extended information about one particular fault. So the request will be 1906 and then the fault DTC number, nothing but DTC number. It could be 9163 as we discussed. So if the ECU is responding to you positively, 5906, I will come back to this XX later. This is called status byte. I will come back to this. So 5906 and also the extended information like fault occurrence. Fault occurrence meaning what? How many times this fault has occurred in the system? One thing. And how much of time taken by the system to set this particular DTC? It's an also information. And aging counter. What is aging counter meaning? Age of the fault. How old the age fault is. Nothing but what happens, aging counter I'll explain when I explain the 14 service. That time you will understand easily. So just remember the name called aging counter. It is talk about the how old the fault is in the system. Okay. And then as we discussed, how much time taken by the system to set this fault, how much time the system is running, how long the system is running when the fault is in active state. These are all the informations are more information about one fault, which we will get on the 1906. Clear?
Yes.
Okay. So if this is clear, I want to explain one more concept, which is status byte, where I was writing XX. For that, let me open another PPT. Where did I keep that? Status byte. It's already there. Okay. This status byte, nothing but, let me see. I have anything. Okay. I'll show in this. It's 19, 19, 19. Can you guys see anywhere 19? 19. Okay, so we have seen 19, 01, 02, and you guys know what is that. 01 sub function, you know why what you will get it. 02 function, you will know what you have known, what like you understood what it will give. So I used to write XX after 01 or 02 or 06. So what is that XS is nothing but it is a status byte, DTC status mask or DTC status byte. So what is exactly the meaning of the DTC status mask or DTC status byte? So as the name suggests, DTC meaning we are already know it is a diagnostic trouble code. Status, nothing but what is the state of that particular fault that will be identified in the status byte. So let me go here. So let's say you are requesting 1901 status byte XX. This is a 1 byte of data, nothing but it's 8 bits. Every bit says 111 thing. Okay, so let me go here. This is that one particular byte 0 to 7, nothing but 8 bits. If the bit 0 is when we say one particular bit, it can hold only two values. One is 0 and 1 because it is a binary. Correct, right? Yes or no? Correct, right?
Yes.
Yes. So if the bit 0 is 0 or 1, what happens? What is it meaning? Test failed. If the one bit, nothing but a first bit, and the second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit. As you can see, the seventh bit, it is for the warning indicator requested. If this particular bit is high, high means 1. If this particular bit is high, then only you will get the warning indicator on the for the driver on the dashboard. Otherwise, if this particular warning indicator is 0, you will not get any warning indicator. Okay, so I hope the seventh bit is clear. I will explain other bits.
Yes.
Okay, so whenever you are writing one particular byte, how would you write? Z- 0, 0. Correct, right? This is one particular byte. This is how it categorizes in the memory. Correct, right?
Yes.
So if the seventh bit, we already discussed, seventh bit is indicates what?
Indicator.
Warning indication to driver.
Warning indication to the driver. So if this particular bit is 1, so how would you read it? In hexa, I'm asking. Tell me in hexa this value. Now the seventh bit is 1. Nothing but there is a camera input request. ECU is not getting that camera input. So it has set the fault and that fault has this warning indicator high. Tell me in hexa.
It's
0, 1, 1. Sorry, hexa is a 7.
7. 1000, you call it as 7. 8, right?
Yeah, right.
So this is how it is in hexa. So wherever I was writing XX, if the warning indicator is high, then it will be become 80. At the same time, we have other bits also to verify. Now let's see what are these other bits says. Okay, this is the bit 0, which is test failed. But every bit will not be applicable in every project, depends on the project. Okay, so as you can see, the bit 0 says test failed. So if that this particular bit, 0th bit, nothing but this particular bit, 0th bit, if that particular 0th bit is 0, what does it meaning?
Test
Nothing
failed.
but, yeah. So no, 1 means it test failed, nothing but 0. Bit 0th bit is 0. If the 0th bit is 0, then it is indicating there is no failures detected. So what is that meaning failures not detected? As I already told you, there will be a task. 100 millisecond task, 200 millisecond task, 1 second task, based on the developer, like based on the requirement, developers will be creating the task to identify, nothing but to read the faults every 100 milliseconds or 200 milliseconds in the system. Whenever you are reading that fault monitoring cycle, if you are not detecting any fault, that time this bit will be 0. Assume there is a fault detected, that time this bit will be 1. Understood? Hello?
Yes, ma'am.
Yes. So if this is clear, the second bit, this is how to, test it. So you can ignore this and this is the result. Yeah. The first bit says test failed in this operation cycle. So what is operation cycle meaning? What is operation meaning? Operation cycle meaning?
Well, it is performing the test.
No, it is like what you perform the test. It's all about how the as a driver how he does, right?
Yes, right.
Testing is not something different.
Yeah, right.
We are doing the same thing whatever the driver does, but we are doing in a virtual car, not in the real car.
I mean, time taken to perform the operation.
No. So operation cycle meaning, assume you have started your driving the car, nothing but ignition on, and you have driven your car for 1 hour and then you stopped. Otherwise, you have stopped, like after 1 hour, you got the traffic and then you have stopped, is a huge traffic, you have stopped it. Again, you have to start, right? Start the car and then, you move on. I mean, nothing but you drive. Correct, right?
Yeah.
That is the called operation cycle. The first one, when you turn on the ignition, nothing but when you turn on your car, that is the first ignition cycle or operation cycle. When you turn off and turn on again due to any condition or anything, due to the traffic or you have just stopped your travel or anything, if you turn on the next time, that is called a second operation cycle. Like this, how many operation cycle you will be doing, everything will be recorded. This is called operational cycle. In this, nothing but in this operation cycle, if the ECU identifying any fault in the system when your car is in running mode, nothing but in the operation cycle 3, in the third operation cycle, if it has found out any fault, this particular bit will be high. If not, this particular bit will be 0. The first bit, this is the fault is detected in the current operation cycle, nothing but whenever you are driving the car. The fault is, if the fault is getting set when while you are driving the car, nothing but on that operation cycle, this particular bit will be high, so that the person who is a serviceman, he can understand there was a fault occurred during the driving. Clear?
Yeah.
So the second bit is pending DTC. So what the name says? Okay. I'll just finish it off this status byte so that 19 service will be getting over. So just now we have seen operation cycle, right? So there is a one fault has been set during the operation cycle, nothing but on that current operation cycle, nothing but when you are driving the car, the fault is set. So that the first bit is became 1, set to 1. But in the next operation cycle, what happens? The fault condition is not present. It was there in the previous operation cycle, but now it is not there. So what ECU will does, that time the first bit it will become 0, and it with the second bit it will make 1, because I am not sure in the previous cycle it was the fault was set, but now it is not set. So I am not writing the DTC. I am still writing this as a pending DTC. Nothing but I am not writing this DTC in the memory because it is not confirmed. It is still pending, which will be identified, which will be telling this information in this second bit. Pending DTC. It is not confirmed DTC. Clear? Hello?
Yes, ma'am.
Yes, the third
It's
bit is
clear.
for the confirmed DTC, where it is confirmed that DTC has been set in the previous cycle and this operation cycle. So confirmed the DTC, nothing but the fault is set in the ECU. That time bit 3 will be high. If there is no DTC, confirmed DTC, if the pending DTC is high, then of course confirmed DTC will not be high, because it has not declared that this DTC is confirmed. It is still in a confusion state that it is not confirmed. So that is the reason confirmed DTC will not be high. It will be 0. Clear?
Okay.
Okay. So in the bit 4, test not completed since last clear. To understand this, I have to explain one of the service, which is 14 service. So anyone has any idea what is 14 service? Okay. The 14 service is to clear the DTC. So when I say clear the DTC, to understand this, I have to explain one more concept, which is active fault and history fault. So can anyone guess what is active fault and history fault?
Active
Active
fault
faults
means
occurs
present
in
fault.
present duty cycle.
Sorry, can you please come again?
Active fault means it is confirmed in present duty cycle or operation cycle. History fault means the problem will occur in the previous operation cycle, but presently it is not there.
Very good. So active fault is in the sense, as you said, it is right. The condition of that fault, nothing but let's say the camera is not sending the signal. So that fault, nothing but there is a one name on DTC for that to identify that particular fault where the camera signals are not receiving by the ECU. And ECU has set the fault that I am not receiving the inputs from the camera. That fault is present. That fault is present when you are driving the car. Nothing but it is actively present on the system. It has been set after validating and after waiting for 5 seconds. That is fault is present. After due to the more air and anything, the blockage has been moved now. So the condition has been removed. The fault whatever was set in the current ignition cycle or the operation cycle, that fault will be moved to the history fault, because the fault condition is cleared. The fault condition is not present now. EC is able to receive the inputs from the camera now because the blockage has been removed. Clear?
Yes.
Yes, if the fault is setting in history, do you really want that fault to be nothing but what is that setting in history meaning? Again, it is writing in one of the memory. Correct, right? So you need to have the memory available for other functionalities. So that time what it happens in the history fault, the aging counter comes into picture. Remember the aging counter which I have explained in the extended information which we will get it.
Yes.
So that aging counter meaning how many times you does the ignition cycle, nothing but how many times. So today you have started your car 10 times, nothing but ignition cycle counter is 10 times. And the car, the what is that? The blockage, I mean the ECU has set the fault that camera is not sending the input was set today. Okay, so and after you started, like you have removed the blockage, there was a cover on that, you have removed the blockage. Once you started the car, the condition has been removed, so the fault has been moved to the history fault now. So once it is moved to the history fault, assume you have started your car, nothing but you have ignitioned your car for 40 times. After the 40 times, the fault which is present in the history, nothing but the DTC which is present in this history fault, nothing but in the memory, that in that memory, the DTC of this particular fault will be automatically removed. Nothing but the age of that fault has been removed. So what is that age actually determining? The ignition cycle. How many, nothing, ignition cycle, nothing but how many times you have turned on, turned off the car. Once after the aging, this counter will be keep on incrementing based on how many times you turn on, turn off, turn on, turn off, turn on, turn off. So once this counter has reached 40, automatically the DTC which is stored in the memory as a history fault will be automatically removed. That is called as aging counter. Clear?
Yeah, clear.
Yeah. If it is clear, so you can, like, as a tester, or as this is the real scenario which we, like, which happens, aging counter. But when you take your car to the service station or as a tester, what you will do, you have one of the service called 14 service which clear the DTCs. When we say clear the DTCs, meaning what? So basically wherever the DTCs are storing in the memory, it will create every memory. This memory usually will be the EEPROM. So it will clear this memory completely. So what happens if any fault set actively, then again the system, again every 100 millisecond it will be reading the faults. Once after the once after reading the fault 100 in the 100 millisecond, whatever the fault conditions are in, still exist, nothing but whatever the conditions of the faults are still present, that faults will be setting on the memory. Whatever were the history faults, because history nothing but it was there, but as of now it is not there, the condition is removed, that history faults will be getting removed in the memory. This is done by the service 14 FFFF. FFFF in the sense you are not providing a particular memory, or particular, you are not telling the ECU to clear the memory of one particular DTC. FFFF meaning you are clearing every memory wherever the DTC is storing. But whatever the fault condition still exists, it will be present because it is active fault. Whatever the faults were present before, nothing but in the previous cycle, and the conditions are not present, which is also called a history faults, those history faults will be getting removed. That will be done by the service 14. Clear?
Yes, ma'am. Clear.
Okay. So if you are clear with this, then in the status byte, so this is the test not completed since last clear. This last clear is using of the 14 service. Okay. So if you have done one of the clear 14 service clear, you have done it, but after that, even though after the clear, if you feel there is, like, if the ECU has been identified there is a fault, that time this particular bit will be set to 1, Otherwise, it will set it to 0.
Okay.
Okay?
I have one doubt, ma'am, from
Yes,
regarding this.
please.
If ignition cycle will turn on, turn off like that 40 times, it will be, we are doing that.
As a tester,
After
you
that,
have to do.
oh, okay. If I do, the fourth bit remains 1, or it will show 0.
Sorry, can you come again?
If I ignition cycle keep on doing 40 times, automatically previous history has been deleted.
Yes.
If fourth bit remains 0 or 1.
Based on the fault. So if you read the fault, if there is no fault, then it will be 0. This is all about the status of a for each fault.
Okay, but one fault will occur in the DTC. If I do 40 times ignition cycle or turn on turn off, automatically it will be clear.
Yes. Nothing but that fault is not at all present in the actively.
Oh, right. If it is in history, it will be clear. If it is
Yes,
in
it will be
active,
clear. Yeah,
if
it
it is
will be
in active,
present.
it will be right. Now I got the point.
Okay.
Yeah.
Okay, fine. So basically all these bits will not be applicable every bit. But yeah, the important bit is this. The first bit is test failed. This is where we will get to know, right, whether the test is failed or nothing but the fault monitoring function which will be present in your software, where it will be doing the fault monitoring every 100 millisecond. If it is detecting the fault, then this fault is active. Otherwise, 0. Nothing but the bit 0 will be high. Correct, right? In this project, only 3 bits are applicable. One is bit 0, bit 3 and bit 7. Warning indicator, confirm DTC and the test failed. Similarly, like this, in your project, there will be only few bits will be applicable. They will not use every bit. If they are using, then you have to test every bit, and then if you are a developer, you have to develop every bit. Clear?
Yes.
Yes, just the last information on this is, where is the status mask? Huh. So wherever I used to write XX to get the status, so that if it is a active fault, if you provide 1901, I have written XX. This if you provide 89, which is nothing but you are looking for active faults, you will get only the number. How many numbers? How many faults are present in active? With 1901, 89, like 15. 15 is the number of count. Similarly, 1902, 89. And then you have requested this. You will get what you will get it. 59, 02, 89 and then DTC. One DTC is 9563. And the status of this DTC also. What is the status? It could be 08 or 89. Whenever the status of each and every fault will be provided in the 1902. Its DTC and along with its status, it will be provided. 89 meaning is the fault is still active. 08 meaning the fault is not active, it is in history state. How would you get to know? That is what we have discussed so far, which is a status byte of every bit. Nothing but it is overall, when you convert that into a hexa, it will become 8908. 89 meaning it is active fault and also warning indicator is high. 08 meaning it is not active, it is only history fault. Clear?
Yes.
Okay. So this is all about the status byte and the 19 service. So we have left out with the 4 service 31, 30, 4, 36, 37. So we will discuss that and yeah, tester present. Okay. So remaining services we will discuss tomorrow. So if you guys have any doubt, please ask me tomorrow because the UDS will be over on Friday. Nothing but the overall class of CAN and UDS will be getting over on Friday. So if you guys have any doubt, please do let me know before that. Clear? Okay, fine then. Thanks everyone. Thanks for joining the meeting. Bye bye. Good night.
Thank you.
Thank you.